Good day, I am Luigi Loberano from BSCE 1A. So, today I will be discussing the 50 word problems involving maxima, minima, and related rates. These problems apply calculus concepts to optimize quantities and analyze changing values in real-life scenarios. Let's begin the discussion. So, the first problem is determine the dimensions of an open top box with a square base and a volume of 600 cm cube that minimize the surface area. So this is the problem number 1, and I already solved it. So let side of x equals to side of x square base cm and h equals to height of the box cm. So ato sa pangitaan ang volume niya. So ang volume niya kay x squared, h equals volume. So ang x squared, h equals 600, and so h equals to volume over x squared. So ang volume niya kay 600 over x squared, so nanatay h. So pangitaan na nato ang surface area. So ang surface area kay a equals to x squared plus 4xh. So x squared plus 4x, so ang ato h kay 600 over x squared. So ato na siya times x squared plus ato sa multiply 4 times 600 equals to 2,400, and ang x ang ato exponent kay ato na siya substitute. So mao na siya equals to x squared plus 2,400 over x. So ang ato area kay x squared plus 2,400 over x. So a prime of x equals to 2x minus 2,400 over x squared. So ato na siya ang pangitaon ni set a prime of x equals 0. So ato na sa differentiate niya, ato sa solve ang a prime of x equals to 0. Ato pangitaan ng x then ang h. So 2x equals to 2,400 over x squared. So 2x cubed equals 2,400, then x cubed equals to 1,200. So nasolve na nato ang x kay 10.63 cm. Then ato na i-solve ang h, and na tayo x. So ang h equals to 600 over x squared. So 600 over x squared man. So equals to 600 over 113 equals to 5.31 cm. So nakuha na nato ang x of h. So this is the answer of problem number 1. So the problem number 2 is find the dimensions of a rectangle with a perimeter of 100 meter that maximize the area. So this is the problem, and I already solved it. So let x and y be sides. So the perimeter is 2x plus 2y equals 100. So this is the perimeter. So equals x plus y equals 50, then y equals 50 minus x. So this is the y, 50 minus x. So area equals, so the area is xy equals x times p over 2 minus x. So this is the area equals xy equals x times 50 minus x equals to 50x minus x squared. So ato na siya i-differentiate. So a prime of x equals to p over 2 minus 2x. So a prime of x equals to 50 minus 2x equals to 0. So x equals to 25, y equals to 25. So ato na solve ang a prime of x equals to 0. Na-find na nato ang dimension. So this is the answer. The answer of the problem number 2 is 25m times 25m a square. So this is the problem number 3, same as problem number 1. Determine the dimensions of an open top box with a square base and a volume of 32,000 cm cube that minimize the surface area. So same as problem number 1 but with 32,000 instead of 600. So this is the problem number 3 and I already solved it. So same as problem number 1 but with 32,000 instead of 600. So let side of square base equals to x, height equals to h. So the volume is x squared, h equals to volume. So x squared, h equals to 32,000. So the h equals to 32,000 over x squared. That is the volume. So area equals to x squared plus 4xh. So area equals to x squared plus 4x. The h is 32,000 over x squared equals to x squared plus 128,000 over x. So that is the surface area. So we substitute h equals to a equals to x squared plus 4 volume over x. So a prime, we differentiate it. So a prime of x equals to 2x minus 4 volume over x squared. So a prime of x equals to 2x minus 128,000 x squared. So 2x cubed equals to 128,000. X cubed equals to 64,000. So x equals to 40 cm. So we solve it. So solve the a prime of x equals to 0. So we find the x then h. So we already find the x. So now we gonna find the h. So h equals to 32,000 over 1,600 equals to 20 cm. So we already have the x and h. So this is the answer of the problem number 3. So this is the fourth problem. Find the height and radius of a cylinder with a fixed surface area of 600 cm squared that maximize the volume. So this is the problem number 4 and I already solved it. And let r equals to radius and h equals to height. So surface area a equals to 2 pi r squared plus 2 pi r h. So equals to 600. So solve for h. So h equals to a minus 2 pi r squared over 2 pi r. So we know that the area a is 600. So we have the h. Now we're going to the volume. So the volume v equals to pi r squared, h equals to pi r squared times h. So we substitute for h. So v equals to pi r squared, h equals to pi r squared times 600 minus 2 pi r squared over 2 pi r. So equals to r times 600 minus 2 pi r squared over 2 equals to 300r minus pi r cubed. So now we differentiate the v prime of r. Set to 0, we gonna solve it. So v prime of r equals to 300 minus 3 pi r squared equals to 0. So r squared equals to 100 over pi. Then we have the r equals to 5.64 cm. So we already have the r, so we're gonna solve the h. So h equals to 600 minus 2 pi r squared over 2 pi r. So equals to 600 minus 200 over 2 pi times 5.64. So the answer is, we have the h is 5.64 cm. So this is the answer of problem number 4. R equals to 5.64 cm and h equals to 5.64 cm. So this is the answer of problem number 4. So this is the fifth problem. A farmer has 240 meters of fencing and wants to enclose a rectangular field adjacent to a river. No fence needed along the river. What dimensions maximize the area? So this is the fifth problem. Maximize area with fencing next to river. One side has no fence, the river, so we adjust our constraint. So I already solved the problem, and let x equals to wide. So the wide is perpendicular to river, and y equals to length. So the length is parallel to river. So fencing 2x. So fencing 2x plus y equals 240, and y equals 240 minus 2x. So the area is xy equals to x times 240 minus 2x. So equals to 240x minus 2x squared. So that is the area, and this is the y. And a prime of x equals to 240 minus 4x equals to 0. So we need to solve this, and now equals to x equals to 60 and y equals to 120. So this is the answer of the problem number 5. X equals to 16 meter and y equals to 120 meter. So this is the sixth problem. A 13-meter ladder leans against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 2 meters per second, how fast is the top of the ladder sliding down the wall when the bottom is 5 meters from the wall? So this is the sixth problem. Sixth problem, ladder sliding, use Pythagoras. So I already solved it and use Pythagoras. X squared plus y squared equals to L squared. So first differentiate 2x dx over dt plus 2y dy over dt equals 0. So this is, and x squared plus y squared equals to 13 squared. So 13 squared equals to 169. So differentiate the 2x over dx over dt plus 2y dy over dt equals to 0. So x dx over dt plus y dy over dt equals to 0. So when x daw is 5, then y equals to 12 because 169, so 169 square root minus 25, so 144 square root, so square root of 144 is 12, so our y is 12. Then 5, so 5 times 2 plus 12 dy over dt equals 0, so dy over dt equals to negative 10 over 12, then equals to negative 5 over 6. So the answer is dy over dx equals to negative 5 over 6 meter per second. So this is the 7th problem. The circumference of a circle is increasing at a rate of 4 centimeter per second. How fast is the radius increasing? So this is the 7th problem, increasing circumference. We relate circumference and radius c equals to 2 pi r. So I already solved the problem, and we differentiate the dc over dt equals to 2 pi times dr over dt. So we're gonna solve the dr over dt equals dc over dt over 2 pi. So dc over dt equals to 2 pi times dr over dt equals to dc over dt over 2 pi equals to 4 over 2 pi and equals to 2 over pi. So this is our answer. So if we gonna decimal it, so this is the answer, 0.6366 centimeter per second. But the answer is dr over dt equals to 2 over pi centimeter per second. So this is the answer of the problem number 7. So this is the 8th problem. The volume of a cube is decreasing at 18 centimeter cube per second. So how fast is the side length decreasing when the side is 3 centimeter? So this is the 8th problem, and the 8th problem, cube volume decreasing. So volume V equals to x cube. So I already solved the problem, and the volume is V equals to x cube. So we gonna differentiate it. So dv over dt equals to 3x squared times dx over dt. So we gonna solve for dx over dt. So equals to negative 18 equals to 3 times 9 times dx over dt. So dx over dt equals to negative 2 over 3 centimeter per second. So dx over dt equals to negative 2 over 3 centimeter per second. So this is the answer of the problem number 8. So this is the 9th problem. The radius of a circle is shrinking at 0.5 meter per second. How fast is the area decreasing when the radius is 10 meter? So this is the 9th problem. 9th problem, area of circle shrinking. So area A equals to pi r squared. So I already solved the problem, and the area is equals to pi r squared. So we differentiate the dA over dt. So dA over dt is 2 pi r times dr over dt. So equals to 2 pi So the r is 10. So 2 pi times 10 times negative 0.5 equals to negative 10 pi m squared over s. So the answer of the problem number 9 is dA over dt equals to negative 10 pi meter squared per second. So this is the 10th problem, and the 10th problem is the radius of a sphere is increasing at 0.7 cm per second. How fast its volume increasing when r equals to 4 cm. So this is the 10th problem. Volume of sphere increasing. So volume is equals to V equals to 4 over 3 pi r cubed. So we differentiate it. So dV over dt equals to 4 pi r squared times dr over dt. So equals to 4 pi times 16 times 0.7. So equals to 44.8 pi equals to 140.7 cm cube over s. So the answer of the problem number 10 is dV over dt equals to 140.7 cm cube per second. So this is the 10th problem. A 10-meter ladder is leaning against a wall. If the base is sliding away from the wall at 1 meter per second, how fast is the top sliding down when the base is 6 meters from the wall? So this is the 11th problem, the ladder sliding. So the given is ladder length equals to, so I already solved the problem 11. So given is ladder length equals to 10 meter, and dx over dt is equals to 1 meter per second. So x equals to 6 meter. So we're gonna find the dy over dt when x equals to 6. Yeah. So we're gonna use the Pythagorean theorem. So x squared plus y squared equals to 10 squared. So equals to 36. 36 plus y squared equals to 100. Then y equals to 8. So step 2 is we're gonna differentiate it. So 2x times dx over dt plus 2y times dy over dt equals 0. So 2 times 6 times 1 plus 2 times 8 times dy over dt equals 0. So 12 plus 16 times dy over dt equals 0. Then dy over dt equals to negative 12 over 16. So we're gonna divide it, and the answer is negative 0.75 meter per second. So the answer is 0.75 meter per second. The top of the ladder slides down at 0.75 meter per second. So this is the 12th problem. Design a cylindrical can with a volume of 500 cm cube that uses the less amount of material, has the smallest surface area. So the 12th problem, cylinder with main surface area V equals to 500 cm cube. So volume is, I already answered the problem, and volume is V equals to pi r squared h equals to 500. So h equals to 500 over pi r squared. So the surface area is 2 pi r squared plus 2 pi rh equals to 2 pi r squared plus 1000 over r. So we're gonna differentiate it. So dA over dr equals to 4 pi r minus 1000 over r squared equals to 0. So 4 pi r cubed equals to 1000, r cubed equals to 250 over pi, then r equals to 3.63. So we have r. Now we're gonna answer the h. Then h equals to 500 over pi r squared equals to 12.57. So we have the answer of the problem number 12. R equals to 3.63 centimeter and h equals to 12.57 centimeter. So this is the 13th problem. A rectangular garden is to be fenced on 3 sides with a wall on the 4th side. If 100 meters of fencing is available, find the dimensions and the area to be maximized. So the 13th problem, garden with 100-meter fencing on 3 sides. So constrain 2x plus y equals to 100, then y equals to 100 minus 2x. So the area is A equals to xy equals to x. So the y is 100 minus 2x. So x times 100 minus 2x equals to 100x minus 2x squared. So we're gonna differentiate it. So dA over dx equals to 100 minus 4x equals 0. So x equals to 25, then y equals to 50. So the dimensions is 25 meter times 50 meter, and the area is 1250 meters squared. So this is the final answer of the problem number 13. So the 14th problem is design the box with a square base and no top that has a volume of 1000 centimeter cube and uses the last material. So the 14th problem is box with square base, no top, V equals to 1000 centimeter cube. So let x equals to base, then h equals to height. So the volume is x squared, h equals to 1000, then h equals to 1000 over x squared. So the surface area is a equals to x squared plus 4xh equals to x squared plus 4000 over x, and we're gonna differentiate it. Then dA over dx equals to 2x minus 4000 over squared equals to 0, then 2x cubed equals to 4000, x cubed equals to 2000, then x equals to 12.6. So we have x. Then we're gonna solve the height. So the height is h equals to 1000 over x squared equals to 6.3. So we have the answer of the problem number 14. So x equals to 12.6 centimeter, then h equals to 6.3 centimeter. So this is the 15th problem. The radius of a circle is increasing at the rate of 2 cm per second. How fast is area increasing when the radius is 10 cm? So the 15th problem is radius increasing at 2 cm per second, r equals to 10. So the area is A equals to pi r squared, then A equals to pi r squared, then dA over dt equals to 2 pi r times dr over dt. So So dA over dt equals to 2 pi times 10 times 2 equals to 40 pi. So dA over dt equals to 40 pi. So the answer of the problem number 15 is 125.66 centimeters squared over S. So this is the 16th problem. A circle's area is increasing at 5 centimeters squared per second. How fast is the radius increasing when the radius is 2 centimeter? So this is the 16th problem. Area increasing at 5 centimeters squared over S and R equals to 2. So I already solved the problem number 16. So dA over dt equals to 2 pi r times dr over dt. So dr over dt equals 2 pi over 2 pi times 2 equals 2 pi. So 2 pi times 2 equals to 4 pi. So dr over dt equals to pi over 5 over 4 pi equals to, so you divided it, so the answer is 0.398 centimeter per second. So this is the answer of problem number 16. So this is the problem number 17. A square's area is increasing at 12 centimeters squared per second. How fast is its side length increasing when the side is 6 centimeter? So this is the 17th problem. Square's area increasing at 12 centimeters squared over second. Side equals to 6. So the area is A equals to x squared. Then dA over dt equals to 2x times dx over dt. And dx over dt equals to 12 over 2 times 6. So 12 divided by 12 equals to 1. So dx over dt equals to 1 centimeter per second. So this is the answer of the problem number 17. So this is the 18th problem. Find the dimensions of the rectangle with the largest area that can be inscribed in a circle of radius r. So this is the 18th problem. Rectangle inscribed in circle of radius r. Use Pythagoras. So x squared plus y squared equals to 2r squared. 2r squared or squared equals to 4r squared. So the area is 4x squared. The area is a equals to xy, then y equals to square root of 4x squared minus x squared. So a equals to x square root of 4r squared minus x squared. So we're gonna, so that's the we're gonna max area when rectangle is square. So x equals to y, then y equals to square root of 2r. So a equals to 2r squared. So the answer is max area is 2r squared, and the dimensions are square root of 2r times square root of 2r. So this is the final answer of the problem number 18. So this is the 19th problem. Air is being pumped into a spherical balloon at a rate of 100 centimeter cube over S. How fast is the radius increasing when the radius is 5 centimeter? So the 19th problem is air in sphere. So dV over dt equals to 100, then R equals to 5. So V equals to, the volume is equals to 4 over 3 pi r cube. So dV over dt equals to 4 pi over 4 phi r squared times dr over dt. So dr over dt equals to 100 over 4 pi times 25. And the answer is 1 over pi. So dr over dt equals to 1 over pi, so equals to 0.318 centimeter over second. So this is the answer of the number 19, the problem 19. So this is the 20th problem. The length of our rectangle is increasing at 3 cm per second and the width at 2 cm per second. How fast is the area increasing when the length is 10 cm and the width is 5 cm? So the 20th problem, rectangle's length 3 cm over second, width 2 cm over second. So the area is equals to L times W. So length times width. So dA over dt equals to L times dW over dt plus W times dl over dt. So dA over dt equals to L is 10, then dW over dt is 2, so 10 times 2 equals to 20. So plus W is 5, then dl over dt is 3, so 5 times 3 equals to 15. So 20 plus 15 equals to 35. So the dA over dt equals to 35 centimeter squared over second. So this is the answer of the number problem 20.